Hi, this is Miss Allen, and today we are looking at the quotient rule. So, before we dive into it, we're going to look at one problem and try to think about how we could do this. So, we're working on exponents, so the quotient rule, quotient means divide, so let's say that we're looking at a problem, and it says x to the 6th over x squared. Well, with the knowledge that you have right now, the best way to solve this would be to expand. So if I expand this, I'm going to have x times x times x times x times x times x. 1, 2, 3, 4, 5, 6 x's over x times x. So x squared. That's what our exponents mean. So the only thing that we know to do at this point is to cancel the pairs with the top and the bottom. You can only cancel with the top and the bottom. So I have a pair here, so I can cancel those. And I have another pair here, so I can cancel those. Then I can count what I have left. 1, 2, 3, 4, only on the top. So I have x to the 4th. But, well, that's really not that bad. But what if we had a problem and it said x to the 56 over x to the 33rd? How many of you guys would want to draw that out completely? That seems like a lot of x's to write out. So that's why we have this quotient rule. It helps us so that we don't have to expand everything out completely every time. So the quotient rule, I'm going to write it out for you. It says that when exponents with the same base are being divided, we subtract the exponents. So I'm going to write it out. When exponents with the same base are being divided, we subtract the exponents. Okay, so what that means, and I'm going to put our kind of base rule here. What that means is if I have x to the a over x to the b, then to work it, I simplify to x to the a minus b. We're going to look at one slightly different way to do it, but it's still the same rule. We're still going to subtract our exponents. I'm just going to give you a specific to help you. So now let's go back to this problem and let's try it. If I have x to the 56 over x to the 33rd, I don't want to expand that. That's way too much to expand. So instead, I'm going to put x to the 56 minus 33, and I'll subtract here and get an answer that says says that it equals x to the 23rd. That's a lot faster and a lot easier than expanding 56 and 33 x's and canceling. Okay, before I throw anything different at you, I want you to try this one. Okay, so you try. So let's try y to the 10th over y to the 7th. Notice they have the same base, and use that quotient rule to help you work this one a little bit faster. Hit pause and try this one on your own, and then I will go over it. So, when we do this one, like I said, we have the same base, so we need to subtract our exponents. So I'm going to rewrite this, keeping the y, and I subtract 10 minus 7. I know 10 minus 7 gives me 3, so my answer is y to the third. Now, what if we have something that's set up a little bit different? Let's say that we go to work a problem, and instead of the top number being larger, what if the bottom number was smaller, or was larger? What if we had x to the third over x to the 8th? So, since the 8 is larger, let's move the 3 to the bottom instead. When we do that, that's going to leave us with nothing on top, but that means that there's a 1 there. So it'll become 1 over our answer. So for this one, I'm going to move this to the bottom and subtract it, because we always subtract the one that we move. So it's going to be x to the 8 minus 3. And like I said, that leaves us with a 1 on top. So now I have 1 over x to the 5th. As a general rule, I'll always move to the larger exponent. So if I were you, I would put myself a little note. Move to larger exponent. That always helps me. So I'm gonna work a couple of examples, but there's gonna be some new things that come up, so make sure that you write them all down, and feel free to pause it anytime and try it on your own. Okay, so here's our next example. We have 2y cubed over y. So there are a couple of things that are different about this one. First of all, we have a coefficient in the front, and this y doesn't have an exponent. So we've got a couple of new things to consider. I know that if there's no exponent there, that means that there's really a magical 1 there. So I like to go ahead and write that in there so I don't forget or treat it as a different number. The second piece is this 2 that's out front. Well, it's only a 2 on the top, so we get to just rewrite it and leave it alone. We don't want to change anything about it. So I'm going to move my 1 up to the top since it's smaller and subtract it. So I have 2y to the 3 minus 1. And that's going to become 2y squared. Okay, our next example is 6z to the 13th over 3z squared. Okay, so very similar, but this time we have 2 coefficients. So we're going to treat those just like we normally would. We can kind of ignore these, and now I just have 6 over 3. So this is really 6 divided by 3. So I'm going to deal with this first. So I know that 6 divided by 3 is 2. So I have a 2 on top. And then I also have to deal with my z's. So I have z to the 13 and z squared. The 13 is larger, so it's going to become 13 minus 2. So my final answer here is going to be 2z to the 11th. 13 minus 2 is 11. Okay, our third example, we have 5x to the 4th over x to the 9th. Okay, so this is kind of a mix of a couple of problems. We have one coefficient, which is a 5, and then our exponents, this time our larger exponents on the bottom. So what's going to happen is that 5 is going to stay right where it's at, but our note up here that says move to the larger exponent, I'm going to move the 4 down, and since the 4 is the part that moved, that's going to be what I subtract. So on the bottom, I'm going to have x to the 9 minus 4. you have to remember that whichever one stays where it is, stays the same, and comes first. The other one is the one that you move is the part that's going to be subtracted. When I simplify, I have a 5 on top, and then 9 minus 4 will give me x to the 5th. Okay, example number 4, we have 4 y to the 3rd over 8 y to the 8th. So I'm going to treat this one like I did on number 2, and I'm going to cover up the variables and just look at the coefficients first. So if I cover these up and I look at the 4 and the 8, well, the 8 is larger, so I'm going to try to just simplify this fraction. And I know both of these are divisible by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. So 4/8 is the same as 1/2. So I'm going to come over to the side and I'm going to start with the fraction of 1/2. Now I'm going to look at my variables. I have y cubed over y to the 8th. In this case, again, the 8 is the larger number, so I want to move the 3 down and subtract it. So that means that my y's are going to be on the bottom, and I have 8 minus 3. So now my final answer has a 1 on top. I keep my 2 on the bottom, and I get 2 y to the 5th. Okay, let's look at example number 5. Number 5, we have x z to the 7th over x squared z to the 5th. This is the first one that we've had multiple variables, and we're kind of going to treat it like we did number 4 and look at them separately. Okay, so like I was trying to say, we'll look at them separately and work with them separately, and then end up with one answer. So if I look at my x's only, I have x over x squared. Well, I like to put this 1 on here because it helps me. And I can see that 2 is larger than 1. So I know I want to move my x's to the bottom of my fraction. So I have x to the 2 minus 1. My pen's going out. 2 minus 1. And then I look at my z's, and I have z to the 7th and z to the 5th. Since the 7 is larger, I'm going to move the 5 up. So I have z to the 7 minus 5. And I'll simplify each of these separately. So this leaves me with z squared over x to the 1st. And we don't have to put the 1 there, but we can. So z squared over x to the 1st. Alright, let's look at another one. Okay, for example number 6, let's look at 7 x to the 3rd y to the 5th over x to the 3rd y squared. Now I have a coefficient and 2 variables. I only have one coefficient though, so I'm going to keep it right where it's at. And I'm going to look at my variables. So I have x to the 3rd over x to the 3rd. We're going to work this out to show it, but since they're the same, it doesn't matter which one you move. So I have x to the 3 minus 3. And then for my y's, I have a 5 and a 2. So the 5 is larger, so I move the 2 up and subtract it. So y to the 5 minus 2. I'm going to have to come below for my answer. So when I subtract here, I get x to the 0 and then y to the 3rd. But x to the 0 we don't need. So my final answer is just 7 y to the 3rd. I hope this is helpful, and if you have questions, please feel free to ask your teachers. Good luck with your work.